Today, we're diving into a fundamental tool every electronics enthusiast must know, the breadboard. Whether you're just starting with Arduino or building complex circuits, the breadboard is your best friend. So, let's understand what it is, how it works, and why it's so useful. A breadboard is a plastic board with a grid of tiny holes that allow you to easily insert and connect electronic components without soldering. Internally, metal strips connect the holes. So when you insert a component into one hole, it's electrically connected to the others in that row or column. The horizontal rows on the top and bottom are called power rails. They're used to distribute power across your circuit, usually marked with red for positive and blue or black for negative. The center section of the breadboard is divided by a horizontal gap that runs across the board. On both sides of this gap, the holes in each vertical column are internally connected. In contrast, the top and bottom rows have their holes connected horizontally. The gap in the center is for placing ICs, so that each pin goes to a separate set of columns. So, what can you do with a breadboard? It allows quick prototyping of circuits without soldering. You can test components like resistors, capacitors, transistors, and sensors. It's ideal for Arduino and microcontroller projects, especially when you're experimenting. Educators and students use it to teach electronics concepts clearly and interactively. And the best part, you can reuse it again and again. In this setup, I've connected an external accelerometer sensor to the Arduino using Grove connectors and a breadboard. Grove connectors offer a simplified 4-pin interface, always providing power and ground, with the remaining 2 signal pins functioning as per the connected module, such as SCL and SDA for I2C communication, or generic digital or analog input-outputs. The breadboard allows me to connect the sensor's I2C lines to the Arduino, while keeping the connections neat. The sensor I'm using is a 3-axis accelerometer and gyroscope module, which also includes an onboard temperature sensor. This type of sensor is commonly used to measure motion, orientation, tilt, and even detect vibration. Let's take a look at the pin connections. Power or VCC pin to red wire. Here the power supply is 5 volts, ground pin to black wire, SCL to yellow wire, and SDA to white wire. This setup is a great way to understand how motion sensors work. You can find the code files in the GitHub link given below. Here, you can see the X, Y, and Z axis readings change when the sensor is tilted. The change in readings indicate the force of acceleration applied from each direction. That wraps up the introduction and demonstration of breadboarding. Thank you for watching and stay tuned for more interesting videos.